As a reminder, please put your electronic devices on silent. If you have to take a phone call or if you need to have a sidebar conversation, please step outside. All right, I am very pleased to introduce Mr. Aaron Mears from Mears Engineering, who's going to talk about the importance of hydraulic analysis. Aaron, the floor is yours.
Thank you, sir. Yes, my name is Aaron Mears. I'm the president of Mears Engineers. So our slogan for our company is we give life to rural Oklahoma. Giving life to rural Oklahoma is really what we're about. It's not really a... When I created this company, it was because I wanted to look at something that purpose over profit. You know, I've worked for a lot of large engineering companies. I've done the conquest thing. I've built the big offices, and it really, at the end of the day, there's just a sense of emptiness. So I wanted to start this company with purpose, and so I really want to focus on rural Oklahoma because that's where I'm from. This is the water I drank my entire life. So it means a lot to me, and it gives me a lot of purpose. So like I said, water is life. I don't think most people in the big cities understand that as well as you guys do in the rural communities. So understanding the water needs for urban versus rural is real essential with what we do on a day-to-day basis. Understanding the challenges in the rural communities, a lot of those challenges are funding. So that's something we also try to work on, and we try to get you guys through, and it's really important. And obviously, hydraulic analysis is phase one to that. So a little bit about my background. In the last 3 years, these are the water systems that we've analyzed and done water system, hydraulic analysis for. I've done many more than this over the 15, 20 years of my career, but these are the most recent. Some of you guys are in the house. Bill Patterson from Davenport, thank you for coming today. You too, Joy. I've got some other clients in the audience, so this is a shout out to you guys. So I guess you could say I know a little bit of what I'm talking about when it comes to rural communities and water analysis. So this one, who truly understands where your water comes from? So this is me when I was a kid. See if you can count the OSHA violations there. You know, the reason I put this picture up here is because what's important with a hydraulic analysis and assessing an hydraulic analysis is you have to understand that everything comes from top to bottom. You've got to understand your system. You've got to know where the valves are at. You've got to know where the issues and the deficiencies are. Sometimes you know what deficiencies are, but you don't know what's causing them. And the only person that really knows that and understands that is your water operator. That's right. Water operators are the most critical person on your system. When I come to your system and I want to talk about your system and find out the water lines and all that, it'd be great to meet the mayor. I love to meet city managers. You know, board members are great. But I need your water operator. They're the most valuable person on that system. One thing I noticed through the years of doing this, one thing that's in common with a failing water system that I come into. Typically, a failing water system has a water operator with low self-esteem or self-worth. A lot of that's self-inflicted, but sometimes that comes from the higher-ups. So empowering your water operator is critical to having a sustainable water system. Empowering your water operator to have pride in running that system. Because that system is more important to your health than the local doctor. But they don't get the respect that that doctor gets. So just remember that next time you see your water operator, maybe give him a raise. One of the other things that I like to live by when I work in this field is by late great Rick Schlegel. Some of you guys know who Rick is. Rick was my mentor. I worked with Rick for many years. One of the things that he really taught me through the years is you do right by your client, they'll do right by you. And what that means is you got to know the difference between a solution and a sustainable solution. Anybody can come up with a solution, but to make it economically feasible, where you can pay for it and make it sustainable so that you're not stuck in a rut, is a real challenge. One of the examples I have is the city of Lone Grove. Some of you guys know down in Ardmore. They had an issue with their wastewater treatment plant. Well, at the end of the day, when the engineering company got done with them, they owed $11 million on a 1 MGD treatment plant. A huge line, which put them in a situation where when their water system failed a couple years later, they had to go on a home building moratorium. They've been on a moratorium for almost 15 years. I'm proud to say that through many, many years of working with them, starting with the hydraulic analysis. They had a $4.3 million project, fully funded, that is going to lift the moratorium probably by the end of the summer. So this is a success story with the difference between a solution and a sustainable solution. They're not strapped with debt now. We're looking at expanding to their industrial park and other projects, because that's the important thing with an engineer that's not going to be there for just a project, that wants to be an engineer for the rest of the time that system is running. We want to answer for the decisions that we make. So when you look for an engineer, make sure that that's the kind of engineer you're looking for. Not somebody that's just going to come in, hit out the project, get that big fee up there, and then not answer your calls after it's done. So remember that. That's what old Rick taught me. So here are some key advantages to having a hydraulic analysis. You optimize your system performance. Everybody knows that your system runs better some days than others. So having that knowledge and understanding of how your system runs on a day-to-day basis throughout the different seasons is really, really critical. It enhances reliability. Listen, when it comes to developers or people coming in or any kind of opportunity to growth, the first thing they're doing is risk assessment. And huge part of their risk assessment is your reliability of your system. Not only your system, but your staff. Listen, your staff is just as integrated as the water system itself is. And these things are important when you're looking at these things. Cost-effective infrastructure. So once you understand the problem and you have a cost on it, you can understand how to tackle that. There's a lot of different ways of doing it. Sometimes when you don't have a lot of money, you can get material costs. You don't have to, depending on the cost of the project. Having an engineer that understands the knowledge of how to circumnavigate these funding agencies and understand what you can do and what you can't do is real, real critical. Reduce energy consumption. A lot of these systems, people don't realize that your booster pumps, if it's a good system, they're running at night when no one else is using it. If your booster pumps are running during the day, you need to look into that and why. Because you want those towers full during the day when it's running, when everyone's using it, and then at night when no one else is using it, and you got static conditions, that's when you want your pumps running. So that will really reduce energy consumption as well. Regulatory compliance, identify deficiencies, we've talked about that. A deficiency equals funding. When it comes to finding and identifying deficiency, especially if you have a consent order, that is eligible for funding. So that's a huge thing with hydraulic analysis. You can find deficiencies you didn't even know you had. So, long-term planning and management. So we'll talk a little bit at the end about the long-range sustainability program by ORWA. Definitely something that you should look into. Enhanced funding opportunities. Again, we talked about that a little bit before. All right, my favorite part of hydraulic analysis, and I'm sure if anybody out there's done them, the data collection. Getting the maps, understanding your pump curves, understanding your tower dimensions, knowing where your pressure reducers are, how many pressure planes do on your system. These things are important in data collection. And guess who has most of that information? The most lowest paid person on your staff. And they can save you more money than anybody else in that building. So them having that knowledge and that understanding is going to save you money. So understand data collections with an engineering company. If you come in and you don't have no maps and you've got nothing, guess what? Your fee just doubled. Because we know it's going to be challenging to get that information. So getting that information together is critical, and the cost of these things. So this is a water demand and usage chart. So this is something that I've kind of developed with my company. We basically, the first thing that we'll ask for is 36 months of water usage data, MORs if you have a treatment plant. We want to know your water production if you have wells. We want to look at your sold, purchased, or if you are making your own water, it's produced. So we want to look at the difference. So the difference of those, minus your flushing and all that, you're looking at water loss. Water loss is key. You want to keep that below 15%. So we want to look at that. And so we break this down to get water demands and peaking factors. And again, I don't want to bore you guys with the details on that, but if anybody's ever seen one of my reports, you know how comprehensive that is, that I use this spreadsheet here. It's a lot of numbers right now, and I don't expect you to read through it, but that's kind of what we do. We look at your total usage monthly, and we break it down to an average day, and then we look at average meters. So, and then we also look at that compared to the production produced or purchased. So, all right, let's talk about storage types. So there are many different types of storage towers. So this is part of data collection. You've got your ground storage tower, which is right here. You've got elevated multi-legged towers. You also got your elevated composite tower. Petosphere or other towers as well that are elevated storage. And then you got your standpipe, which is your most classic water tower that you'll have in the state of Oklahoma with water usage on systems. You get it on top of a hill. Standpipe's definitely, ground storage is the cheapest, but standpipe's the next cheapest. So. I'm flying through this. I need to slow down. All right. So, storage capacity. What are we looking at when we're talking about storage capacity? All right, so the information typically we want to look at when we're looking at capacity. This is an elevated storage tower that's actually getting ready to come online in Lone Grove. If you guys ever come down there on Highway 70. When you're looking at your tower, we want to know the diameter, we want to know the height, and we want to know the usable storage. And what do I mean by usable storage? Well, a standpipe tower, you'll have a total volume of that tower, but according to DEQ, anything, the closest meter is what dictates how the low water level can be in that tower. You need a maximum of 30 feet fluctuation in the tower, which can vary depending on system to system. But that meter, so if you have a meter at the base of a water tower, which is a typical thing, that means the first 57 feet of that standpipe tower does not count as usable storage. So when you're looking at a hydraulic analysis and you're assessing your water towers and your volume and your capacity, you want enough water for daily usage. You want enough water for fire suppression if you're on a municipal government. So a lot of people, they get confused thinking they have enough volume, but they don't understand that that volume is total volume and not usable volume. So what these reports do is we'll assess that, we'll look at that and truly understand that. And if you have a deficiency, guess what? You need another water tower. So that's when we start that march of trying to get you guys another water tower. So storage capacity is real critical on a hydraulic system. Because typically, if the system is working, operating, functioning properly, the water tower is pretty much what dictates your pressure planes. So it's real critical when we're looking at that. Now with data collection, typically we'll put pressure loggers at the base of your water towers. We'll put them at master meter areas. We'll also put them close to your booster stations, different parts of your system, just to completely understand the pressure planes of that system. And so those areas are really key for that kind of stuff. So I will talk about interval on these data loggers and how it was critical with some of these projects that I've worked on in the past. I think for a water dork, it's pretty interesting. So you guys might like that. So. Okay, and as I was saying, another thing that affects your system and that's critical, that typically a water operator knows exactly where they're at and how they're set, are pressure reducing valves. You have pressure reducing valves that typically step down your pressure if you're going from one pressure plane to the next. Some systems I've seen them use gate valves as a pressure reducing valve. It's not very efficient, but it works. Now if you want to increase the pressure on the system, and if you're going uphill or you're increasing your pressure plane, then you'll have to have a booster station. Now I'll tell you, the booster station, when it comes to data collection, is typically one of the hardest things, information to get from a system. They're really good at getting me the motor information because it's right there and there's a nice little plate, but the pumps are not, they're usually down in there, they don't keep the paperwork, so trying to figure out what these pump curves are is really difficult. So if you can get that information up front, or if you have a booster station or any kind of pump on your system, keep that information. Keep records of the specifications on all the improvements that you have. Catalog it, put it on the computer, digitize it, save it. Because if you have all of this information up front, you can save thousands of dollars on a hydraulic analysis. So again, just keeping this kind of stuff, pressure reducers and booster station information, is very important when you're doing a hydraulic analysis. Also telemetry. Telemetry is another important thing. A lot of these booster stations talk with water towers, or you're talking to a plant, and understanding how your system behaves is really, really important. Now, one thing to understand is when we're modeling a system, we're looking at peak conditions. So make sure that you understand that, you might have a telemetry system that's really integrated, but it's not running during your peak time. You're just filling a tower using it. So it might not be important for the hydraulic analysis itself, but when we're looking and troubleshooting and identifying deficiencies in how water towers are behaving, if your water tower's not getting a proper cycle in there, well then maybe we need to look at the telemetry. So the data collection and actually the raw data can actually help on troubleshooting your digital equipment as well as your hydraulic equipment. So, oh, and system topography is another real critical thing. So if you have a real mountainous area, real hill area like in southeast Oklahoma, I've got some clients down there, you're gonna have a lot of different pressure planes. And understanding how that works on your system and can overwork your system. I've got one system right now, they've got 700 meters, they span 2 counties, and they have 1 booster station. So if that booster station goes out, what do? You have no residual. You have no backup, no redundancy, you're just dead in the water. So you want to make sure, that's another thing these analyses do, is we look at deficiencies when you're looking at the day-to-day operation and the understanding of that. Last but not least is your distribution and production system. So this part of the system is actually my funnest part. I like to make really cool wall maps that are laminated with the lines on it. So every time I come down there and you talk to me about this line and you're looking at me in the eyes talking about this line at Old Country Road next to the barn, I have no idea what you're talking about. We can just stand over there and look at this map. That's a universal USGS map that we can all understand each other and we can all communicate. It's a beautiful thing. It's definitely a byproduct that I like to produce once a model has been completely done. And if we've done any improvements on it, typically I'll wait until the improvements are done before I issue the laminated map. For some of those systems out there that haven't got your laminated map, we'll get that to you, I promise. But once we get those improvements done, I want to make sure they're done and finalized before we laminate that thing and put it on your wall. But I think this is really important too, because when you have developers coming in, it helps be able to communicate nicely where they're at, what they're trying to do. Oh, you're trying to tie onto a 2-inch line, and you want to put 60 houses, guess what? You're going to have to bring that line farther up, and having that representation and that understanding ahead of time is huge and critical to a sustainable and effective system. So this system here this is South Coffeyville's system. They had a really, really unique issue. So the way their system works is they've got a 6-inch line that goes to Coffeyville. So they actually have two systems that buy water from Kansas and Arkansas. So you don't necessarily have to produce the water here in the state to use it. So that was kind of an interesting deal. But so they have one master meter, goes down the 6-inch line. Then they've got on 169, they've got a little booster pump sitting there on the side of the road. Well, when they built this booster pump, you can see the line comes into the building, and then it comes out, and then it goes down to the water tower. So whenever they need to fill that water tower, it communicates to this booster station, fills the tower, and then they use the tower during normal operations. The problem is, the city grew out this way. So when this tower is full and they need water, the water can't go back through that 6-inch line. Does anybody know why? Because booster stations have check valves. They flow only one direction. Whoever built this, I'm assuming they did it before the system grew out this way. But basically what's happening is they have a 3-inch line and a 4-inch line that's carrying the water through. So I called this mayor and I said, so what happens if Coffeyville shuts their water off? What happens to your system? Oh, I don't know, it's never happened. Well, I said, according to my model, if it happens, it's going to be the apocalypse for South Coffeyville, because this whole side of the system just shut down. So they're not even using the water tower they have. They're using the pressure from Coffeyville's system, And if that goes down for whatever reason, they're dead in the water. They wouldn't have known this without a hydraulic analysis. And you want to talk about a deficiency that can get funding? That's a deficiency that can get funding. So now we're looking at rehabbing this thing, putting a control valve between these two 6-inch lines that will close when the poop pump is on, fills the tower, and then opens whenever they need a free flow back to this side of the system. Very small and inexpensive fix to a huge problem. And that hydraulic analysis was key to determine what needed to be done to fix that problem. The next I'd like to talk about is data analysis. So this is after we've built the model, we've put all the towers in, and now we want to calibrate the model. So this little chart here was a pressure logger. So the city of Morris did a hydraulic analysis. Actually last summer we did a hydraulic analysis, and I sat a pressure logger at the base of the water tower. I had the interval set every 30 minutes or every hour, I think it was. So it was only logging data every hour. And so the data logger was kind of a wavy line. Kind of like that. It was at, it never got above 60% full of the tower, because basically, we'll talk more about the Morris system later, but their booster station wasn't working and they were using master meter tower pressure, so the water was just cycling in there. They get DBP issues during low flows because the water would just stay in there for weeks until it got sucked out, right? But I couldn't prove that, so the DEQ is saying, we don't know if they need a tower. We need additional information. We think that they might have broken lines and they just need their leaky lines repaired. So I sent my data collector field guy back out to the system, and I wanted him to set the pressure logger at the highest point where we were proposing the tower, but your highest point is typically where you're going to experience the low pressures first. So he sat it there, and I said, also, when you set the logger, I want you to set it for 15-minute intervals, not an hour. So this time we set it for 15-minute intervals. And if you're a hydraulic geek, that's awesome right there. That's a cool little thing to see there. It sucks for the system, but it proves they need a water tower. So either you have leaky lines that break at 9 o'clock at night every night and then fix themselves at 10:30, well then I want to know who built those water lines. I want their number, and I want to definitely use them. No, just kidding. To have that kind of control. Or about 9 o'clock, 3 out of the 6 nights, for 7 nights we logged it, at 9 o'clock at night, their tower completely ran out and their system went below 25 PSI. Right there proves they need a water tower. So guess what they're gonna get? They're gonna get a water, hopefully they're gonna get a water tower. DEQ's here yet, they haven't proved it yet, but I proved that they need a water tower. And that comes with data analysis. All right, back to the South Coffeyville system. So again, I wanna talk about what are the 2 main components that we're looking at when we're watching a hydraulic analysis. So if you're having issues because your lines are breaking or you've got deficient equipment, I cannot see that in a model. The model is going to assume that there's no I&I. It's just going to run like they're perfect lines. They're going to have elevations. You've got line sizes and you got demands and you got sources. So what are the 2 things that we look at when we're looking at a water model? We're looking at velocity and we're looking at pressure. Velocity is going to talk about, we're looking at volume, we're looking at your capacity. So you can have high, and this is something that's very, very easily mistaken. You can have a high pressure system and you think that you have the volume. But if you have a high pressure on a 2-inch line, you do not, it's lower volume. So there's a difference between the volumes with the same pressure. It's kind of a crude joke. If you want to know the details of the joke, come ask me after the presentation. But it has to do with volume, the lack of volume. So you open that hydrant up and you don't have a lot of volume. If you have a lot of volume, it's just going to gush for a long time. The pressure's not going to change. If you don't have the volume, you open it up, it's going to drop real quick. So that's the difference between the 2, and it's real easy to mistake. Putting the pressure logger on there, oh, you're 60 PSI, yeah, it'll build 60 houses on a 2-inch line. You want to have an engineer assess that because you're going to need a 6-inch line. Anybody out there have a municipal system and you got buildings that need fire flow? If there's no 6-inch line around that building, guess what? You don't have fire flow. You need a minimum of a 6-inch water line to have adequate fire flow. So remember that volume is key. Volume is key. Let's talk a little bit about Lone Grove. So Lone Grove is one of my oldest clients. Again, they had some major issues on their system when we met them back in 2016. That's when I got started, or 2015 was when I got started on that. So when I came to Lone Grove, they were having issues experiencing low pressures on the south end of their system. Again, as I told you earlier, Lone Grove didn't have the funding to fix what they needed. They needed a tower, they needed more wells, and they needed upsized water lines. They needed a lot. And so since they were on a home building on a moratorium, which by the way, if you're trying to get funding, do not go on a moratorium, because the funding agencies will not fund you. That's the first thing. Really, before the last few years, you almost had to have a consent order to get any funding, which I think is counterproductive. I mean, I had one client, or not one, potential client, it's not a client of mine. And this is a great example of being proactive versus reactive. This is another mistake that I see on a lot of systems. I had this guy, he got voted out, obviously, he was still a council member, but he got voted out in his #1 position. When I came to him and I talked to him about a hydraulic analysis, his words were, we don't need a hydraulic analysis. When we get a consent order, the engineers will come. This is what I like to call a reactive philosophy method. And trust me, every client that I come to that has a failing system, 9 times out of 10, that was their philosophy. They waited until someone would come save them. Nobody's coming to save you. You have to take control of the system yourself. You have to be proactive and not reactive. Because guess what's going to happen? You're going to get a consent order. Yeah, those engineering companies are going to swoop from the heavens. They're going to give you, you know what? They won't even sign and say, yeah, you need a new treatment plant. How many times does that happen? You got a little faulty turbidity and they're ready to build you another plant next to it. You know, they want to get that fee up. You know why? Because their fee is based off that total construction cost. And this goes back to having an engineer that's going to be there to be your engineer. Mears Engineers. People make mistakes and call me Mears Engineering all the time. But the reason they do that is because engineering is all you know. You don't know the philosophy of Mears Engineers. We're not an engineering company. We're an engineer. We're here to be your engineer. We want to be there when the project is over. And that's the important, that you have to look for an engineer that's not going to just be there to get the project done and then not answer your calls after it's closed out. You got to have someone that's going to answer for it 5 years from now, 10 years from now, 20 years from now. What's the next project we're going to do? Let's get a capital improvement plan together. Let's get a game plan. Because if you want to get funding, you got to reduce your risk. If you think that these funding agencies are nonprofit organizations that they don't do risk assessment on their financial assets, you're mistaking yourself. So you've got to reduce that risk. You've got to be a player in this game, and you've got to be serious if you want to be taken serious. So Lone Grove, they wanted to take their system back, and it took me 10 years to do it. We finally got a $4.3 million project, fully funded. Fully funded. It took 5 different agencies to do it, and trust me, it's a pain in the butt to deal with them all the time because they all have their little checklists they need and the little hoops I have to jump through, but that's what you pay me for. So I don't mind doing that. But now they're sitting in a position where they're not strapped with debt, they're off their moratorium, they're getting ready to get 500-600 homes that's moving in there, we're getting ready to expand their sewer lines to their industrial park. They are moving forward and they are advancing. And they are moving with this growth in the rural areas, and we all see it, and we need to be prepared for it. People are moving back to the rural communities. This is something that I've noticed all over the state, especially in lake communities. So this is something you've got to be on top of. You've got to stay on top, and you've got to get the hydraulic analysis done. Either you do it out of your pocket, there's plenty of funding agencies, and we'll talk about that, but this is step 1 to having a sustainable, being proactive on your system. Is a hydraulic analysis. So what their issues were is they had half their system is on the south end, which the slide cut off here, but they were having low pressures down here. Well, all the water, which the water never likes to be around the people, I've always noticed, is all in the north end. So their water capacity, all their towers are up here. half their system is being fed by two 6-inch lines. Two 6-inch lines that go across that highway. So guess what happens if one of those 6-inch lines go down? You've got about 500-600 gallons a minute a day, or 100 gallons a minute going through a 6-inch line. If you've ever seen a water line that's got high velocities, it usually only ends one way, and that is exploding. I've seen water lines blow out of the ground with velocities as high as what could go through a water line, that under capacity line. So they needed storage capacity and water volume on their south side. So we put this 500,000 gallon guy right here on the south end of Highway 70, and that'll provide water. We put a well up here. We upsized the lines here and here to a 6-inch to get the volume of all the water to the tower over here. And then the tower will feed the south end of the system. We set the tower height equal to the tower height of both of their other towers. So their system's all on one pressure plane. And that's going to take care of the moratorium that's going to be lifted. So Lone Grove's really happy, and happy they got a hydraulic analysis done. All right, let's go back to the city of Morris. So what was going on with this system is they had a master meter up here that's tied onto Okmulgee. They've got an 8-inch master meter, goes through an 8-inch line, booster station right here, which needs to be restored. They had a winter storm, so their booster station had all their piping underneath the building is in a vault, so it's not underground. What happened was that vault filled with water in the wintertime. Water froze, all the piping froze, so everything in there just exploded. So their booster station went kaput. So this booster station is communicating to a little control valve that's located right at the beginning of their system that dictates to this tower when it's full. So that control valve opens up, booster station kicks on, control valve opens up, fills up the tower gets full, and during the system running. It gets late at night, past 9-10 o'clock. Booster pump kicks on, control valve opens up, and it fills up again. So when the tower's not running, this valve closes. And the reason they do that is so the water doesn't come back this way. It stays in this area. And then this master meter has the pressure to run their system up here. But that booster station wasn't running, which means their control valve wasn't operating properly. So when you set a pressure or a data logger at the base of the water tower, it was only cycling about 10 feet, about 40% of the tank. So the top 60% of the tank, they weren't using. They had a 60,000 gallon pedosphere. They used 100,000 gallons a day on average. On average, that's not even a peaking factor. So some of the other days, they were using double what storage capacity they had, and then the storage capacity they had, they were only using 40% of it. So that's why the water towers were running out in the middle of the day. Well, at 9 o'clock at night, as you guys saw that. So right here, this little peanut shape, because I asked them, I go, where's the low, I'm gonna guess, your low pressures are happening right here. How did you know that? How did you know? Because your topography. Your topography tells you everything on one pressure plane system. So we're looking at putting a water tower right down here on the top of that hill that's gonna satisfy that daily demand. Had a little bit of a kickback from the DEQ. Well, why can't Okmulgee provide the storage capacity? Well, first of all, that's not a thing. People don't buy infrastructure for your system, okay? That's not their responsibility. But if they had 1 million gallons of extra storage capacity, let's just say. Okay, so their tower's over here. So what's gonna happen when that tower runs out of water? Does anybody can tell me? Anybody? That means this booster station is going to kick on, right? What happens when that booster station kicks on at 12 o'clock and at noon? It's going to run all day, and then it's going to run all night. And it's going to do that every time that water tower runs out. So you put your tower on that side of the booster station, okay, great. Make sure you're buying more pumps, because now you took a 15-year life pump to 3 to 5 years, because it's running all day. So why even have a tower if you're just going to have a booster station run your system all day? So So again, that's another thing the engineers can defend for you, can understand how these systems operate and understand that they're very integrated and there's an order of operations on how they need to run if you want a long, sustaining system. And design life is something that is factored in to improving a system. So that was really important to make sure that we got that tower is critical. That's what they need to fix their system. You want to fix deficiencies? This is how you do it. All right, City of Bonita, my favorite place. A lot of people heard of this place in the news. What's supposed to go off? This is one of my favorite systems, not just because of the amusement park you guys have all been hearing about, American Heartland. That $35 million, I set that estimate, so if you guys want to know. That's something that we've been working on. Signed the NDA last year, back in April. Operation Lazy Hawk is what it was called. They called it the Palace up at the Capitol. That was the code word. That's why they're calling it the Palace District. So the new annexed area out there in Bonita is called the Palace District. The reason I love this system is it was the most complicated hydraulic analysis I've ever done. I've done some pretty large ones. Lone Chimney is probably the biggest one I've ever done. That thing spans 7 counties. It's a huge system. 13 systems are tied onto it. I don't know. But this has, I think, another 12 master meters on 6 different systems. Funny thing is, a week before I present, and I do this on purpose, I send a copy, make sure that they get a copy of it before they put it on the agenda. So I send this thing a week before it goes on the agenda. When I sent this thing, that's when they decided to tell me they had 12 master meters. So I ran the system thinking it was going to be perfectly robust. Oh yeah, by the way, 60% of our water that we sell, we don't use. We sell it through master meters. Okay, well maybe you should tell me that so I can run your system. So I frantically redid their analysis a week before the deadline and added the 12 master meters. What I love the most about this system is right up in this area. I think it's, yeah, right in this area there's a new development. It's either in this area or in this area, somewhere in here. There's a master meter that goes to Big Cabin. Does anybody know where Big Cabin is? No? Big Cabin is, I guess, grown a lot over the years. It had a little 3-inch or 4-inch master meter, I don't know. But when I ran the model with the demands that they gave me, this area went negative pressure. I said, well, you need to upsize these lines. That was my recommendation in the analysis. And when I do some of these analysis on my first, because I go and I do the analysis and I present it, and then I tell them my findings if they agree with me. Right, sometimes when I present the first analysis, I don't have the data logger, so I'm doing a lot of guessing. Sometimes it's kind of fun to do that. Because I come back up and I'll do another presentation when we add the proposed project. So we have a hydraulic analysis presentation, and then I do the engineering report presentation. So the hydraulic analysis is really just to make sure that it's accurate. Because a lot of data collection, you can call every day, you can meet with the water operator every other day, you can go there once a week, but until you get all the old timers in one room, you're really not going to know what's going on. Oh yeah, that line was abandoned 16 years ago. No, that one's not there. You know, you got to get everybody that's been on that system for decades and decades in the same room. And sometimes with these board meetings, it ain't gonna happen till they're required to be there that night. So I was at Bonita, and I told them that they're having negative pressures up here. Another thing a lot of these little municipalities like, they got the little old lady in the back. You got the lady in the back, it's not on the council, but she's the little Gabby Bessie, you know, she likes to, some of the gossipers, but she likes to be engaged in the city, which I love those people, I really do, because, you know, sometimes if I'm not there, they can tell me, check. Oh, there we go. They can tell me, you know, what happened the weeks I wasn't there, or the months I wasn't there. Well, the city of Bonita has a little old lady in the back, and when I was telling them that these pressures were negative in this area, I don't know if it's something I'm doing or check, mic check. Mic check. Hello. All right. I think it might be dying here.
Yeah. Just yell like you do to me.
I could yell. Did you guys hear me in the back?
Yeah.
Give me a few minutes. Okay. Just a few minutes. I'm gonna talk in this right here. So I had the little old lady in the back, and I told them that those pressures were negative up there. And they're like, well, I don't know about that. I don't think they are. I think your model's off. And then she chimes in. Wait a second. Turn around. She goes, they did some fire flows back there last year, and I remember they opened that hydrant up, and it just made a funny noise. I'm not exaggerating. I turned around and I go, thank you! Because it proved that my model works. And you know, sometimes that stuff we just need that little bit of juice every once in a while. Because it just feels good that that hard work that I put into it paid off. It's something they didn't even know was wrong. They didn't even know it was wrong. Do you like this or do you like me screaming? What do you guys like? They didn't even know it was wrong. So that was something that was really cool. So identifying deficiencies when they don't know they're there so that we can get it taken care of before it fails. Proactive, not reactive. Again, that's what we want to talk about, sustainability. So as you guys should probably want to know a little bit more about the amusement park. So I did this 6 months before Mansion Entertainment came knocking on their door. And this is important to hear. They had questions. If there wasn't somebody that did what I did, they wouldn't have got the answers, and that might have gone down the road. And some of you guys know what I'm talking about. Having that hydraulic analysis before the developers show up is critical. It was critical with this because if they didn't, we wouldn't be talking about the Palace District. They would be out there in their own independent water district, drilling their own wells, build their own wastewater treatment plant, and Bonita would not reap a dime from that. And that's my whole passion, giving life to rural Oklahoma. Water is life. You want to bring life to your town, you've got to bring developers, you've got to bring growth, you've got to bring that. And the only way they're going to come is if you have that sustainability in mind. They have to know their assets are not at risk because of the water they're buying or the sewer they're taking it to. It is critical, and it was critical for the city of Bonita. So it took me 6 months to get the cost estimates put together, sitting in through meetings, didn't get paid a dime. That's preliminary engineering. You guys know how the game's played. Until we get the estimate and the proposal put together, all that work is done on the front end. So you do the front end, you get the cost estimates put together, you get the proposal put together, then that's whenever the engineering starts to sign the proposal and go. So it took me 6 months to get this thing put together, but I was okay with that, because that's the game I play. But essentially what they're gonna do is they have a 30-inch line here. They're gonna run a 24-inch line down the highway. There's RV parks right about here, amusement parks right about here, there's some other things I can't really discuss what other things are out there. But they need 1.5 million gallons a day. How many people out there can you, if somebody came knocking on your door and asked for 1.5 million gallons a day, what would you say to them? Exactly. I mean, is it hot because you know, or is it hot because you have no idea what that would look like to even get to them? Exactly. And having the analysis and that engineer in place, letting us take the wheel is the right answer. You want to have the answers for them. You want them to know that you know your system. Not a week from now, the day they show up. That means you got to have this done before they show up. Bonita showed up, and that's why they're in the news. $35 million, that's just 1 year. They're going to need to get the amusement parks, going to be another $30 million. And then we're not even talking about roads and telecommunications and all of that stuff, but that is why these are important. None of this would have happened if they did not have a hydraulic analysis. That is why I'm bringing this up. This is why this is so important. All right, now let's talk a little bit about ORWA. One of my favorite programs, and I guess you guys have been listening to me for the last 45 minutes, Long Range Sustainability Program. Who all knows about this program? Who's all a part of this program? Who wants to be a part of this program? I highly, highly, highly recommend getting a part of this program. This is step one to sustainable solution. It doesn't cost you anything to get on the internet, look this up, fill out the application, and get going on this. Because the hydraulic analysis is part of this program. But it does asset management, risk vulnerability assessment, emergency response planning, business, financial policy development. They help you with your books. They help you with the front end stuff. That's part of sustainability. Capacity development assessment, Capital improvements planning, this is stuff that the engineer does. I'm actually doing about 3 or 4 of these capital improvement plans. They're great tool to have. They map out what you need done, when you need it done. You know, that's how you do at your home when you finance yourself, right? I mean, you set up a budget. You know what money you have 6 months from now, a year from now. That's what capital improvement planning does. It gives you a roadmap. You identify the deficiencies, you put a cost, you identify projects, you break it up, and then we plan on that every year, every 3 years, every 5 years. Let's do a project, let's get this done. And it's gonna take years to get a system back on track if you've fallen off. And once you get on track, don't fall off again. Keep it going. I see sometimes a lot of turnover with boards or council members. You've got to keep that alive. Keep those people around, or have the capabilities of being able to pass that information on. And the only way you're going to do that is through record keeping. So keep that in mind next time you got to file all that paper away, or you got to put something and scan it in and put it in a document folder. It is critical for tomorrow. It's not for today, it's for tomorrow. So keep that in mind. Just remember that. Leak detection, that's something that's really great. They also do, they'll check your master meters. So if you're suspecting your master meter's not running properly, they'll go out and they'll check it for you, they'll calibrate it, make sure it's running properly. Mapping, distribution, collection system, that's something that I do. Mutual aid, sooner warn, operation and maintenance, planning development. Optimization of system, we talked about that, that's a hydraulic analysis. Rate analysis, this will talk to you about the money. How much you charging? When's the last time you raised your rates? Do you have an automatic trigger to raise the rates every percentage every so many years? If you don't, I suggest getting that. Because one thing I do ask when I come to these meetings, I go, are you doing a rate hike in this meeting? I'm not going to be there. I don't want to be at the meetings where you do a rate hike. But to get rid of that uncomfortable feeling, you got to have something in place that's going to raise that every once in a while. Okay, we got 3 minutes. Sanitary sewer evaluation. This is something that's really costly, but it's really important for your I&I issue. Water source protection and cleaning, water loss auditing. Are you prepared? Are you ready? Are you ready to bring your system back to life? Do you know where the money's at? Do you know if you can serve 1.5 million gallons today? Well, to get started, you got to get the funding and understanding where it's at. Council of Governments, the COGS right here. Check out where your local listing is. Talk to your local COG. They can help you with the funding. FACT, there's the website for OWRVs, FACT opportunities, IHS tribal funding. A lot of people don't know this. If you have $1 million total project, and you have 25% Native American tribe on your system, guess what? The tribe will pay 25% of the total construction cost. There's other opportunities with the tribes. DWSRF loan forgiveness is a huge one. RIG grant. I get more systems that pay for hydraulic use using this right here, or a REAP grant, PREP grant. There's interim financing, many more. You just gotta look. Go to the COG, talk to your COGs. And then this is a little something that I'm starting. It's a nonprofit. So Mears Engineers, we give life to rural Oklahoma. The Redmond Project is giving life to rural Oklahoma through community action. So this is something that we're starting. So one of the things I'm gonna start getting into is going to your high schools. Do a hydraulic analysis, I'll go to your high school and talk to your kids about it. I wanna get kids excited about it. That's a volunteer, it doesn't cost you anything. I wanna get kids in rural Oklahoma, just like me, excited about math and science, technology, engineering, math, you know. Science is all around you, and I wanna show them that. But we do other things, senior citizens events, veteran affairs, drug and alcohol treatment. We just want to give to the communities that give to us. So this will be established within the next 6 months, so be watching for that. Does anybody have any questions for me?
No.
Other than when's lunch? Can we stop this for lunch? All right, I don't know if no questions are good or bad thing, but I appreciate it. My information's right here. If you guys want to reach out to me, feel free to give me a call, mearsengineers.com. Thank you all for joining me. Thank you.
I'm not clapping because you paid my...
All right, folks, lunch is being served.